Okay, good morning everyone. Now we're going to continue our lesson into chapter 9, lesson 5, integrating special power of trigonometric function. You can open your book, page 449. Page 449. Yeah, so I'm going to take some material from the book and I'm going to add some also from the book that I have. Yeah. So there will be a lot of combinations, there will be a lot of variations for this method, for this technique. So I'm gonna take several meetings to discuss about this method. Okay, so basically this method is used when you have a integral problem with a trigonometric function with a certain power. For example, sine square x or cosine cube x or secant power 5x or even combination of them like secant square x tangent power of 3x or sine power 5x cosine square x. So all of those kind of problem with the special power of trigonometric functions and the product of them can be solved with this method. Okay, so let's start with the first one. So the first one is when you have a power of sine or cosine or combination of both of them. Like for example, sine square x, cosine cube x, or even sine square x, cosine square x. So yeah, we've got so for the first one, we're gonna discuss about the integral of power of sine or cosine of both. Okay, so now we're gonna learn about if the first one, let's put an A here, if the power is an odd number. So this is easier. So if the power is odd number, it's easier to solve it rather than if it is even number. Okay, so I'll give you the first example. For example, let's say example one, and or yeah, I can take the example from the book. Example one on your book, integral of sine power 7x. Okay, so the first step is to split the sine power of 7x into a single power of sine with the rest of them. So split one power, sine x. If it's cosine, then split cosine x. If it's cosine power 5, for example, then split cosine power 4x and cosine x. And by the way, I forgot to tell you that for this method, we will need a lot of trigonometric properties. Yeah. So of course, in the quiz or in the test, I'll give the properties, but it's nice if you can memorize some formula that is really used quite often. Okay. So and then the next step is to change the sine power of 6x into sine square x power of 3. So we change the sine power of 6x into sine square x being power. Yeah, and of course, if the power is odd, because you take one, a single power, then the power will be even, and of course, it can always be expressed as sine square x or cosine square x power of something, right? Okay, and then the next is to change the sine square x with the Pythagorean property for trigonometric function. So this is 1 minus cosine square x. I hope you remember this formula. Well, you're supposed to remember this formula. Okay. And then I will expand the cube, so it becomes integral of 1 minus 3 cosine square x plus 3 cosine power 4x minus cosine power 6x times sine x dx. Okay, I hope so far you're following. Now the next step is actually to use algebraic substitution method with the u is equal to cosine x. So the du is equal to negative sine x dx. Okay, so your problem will be equal to integral of 1 minus 3u square plus 3u power 4 minus u power of 6 times sine x times dx. So dx is actually equal to du over negative sine x. So now let me explain to you the goal of separating the single power of sine here is actually the idea is to keep the sine and change the rest into cosine. And then after that we use this assumption and then we use the algebraic substitution method. That's why it's really important to keep the single power of sine, because then that will be the cancelling factor for the derivative of the inside function. Yeah, I hope you understand how this method works. So basically this will be equal to integral of 1 minus 3u square plus 3u power 4 minus u power of 6 du. And you can do this. So the solution is u minus u cube plus 3 over 5 u power 5 minus 1 over 7 u power 7. Okay, and then don't forget to put it back to the cos. Oh, by the way, I forgot there is a negative. So negative, positive, negative, positive. Yeah, so it's equal to negative cosine x plus cosine cube x minus 3 over 5 cosine power 5x plus 1 over 7 cosine power 7x plus c. Yeah, so that's the first one. And then what if we have the combination of both sine power of, let's say, sine x times cosine x dx, but this is one of them is odd and one of them is any number. Let's say this is 3 and this is 4. So so again actually it's the same. Basically you separate single part of the odd one. Yeah, and then of course the rest is sine square, and then you change the sine square into 1 minus cosine square, and this can be combined with the cosine, and the works will work the same way. So that's if the power is an odd number. Okay, so if the power is odd number, the formula, the trigonometric formula that you need is actually the Pythagorean property for trigonometry. Sine square x plus cosine square x equals 1. Okay, now what if the power, now this is 1b, yeah, 1b meaning like still power of sine or cosine or combination of both, but the power is an even number. Yeah, the power is an even number. I'll use have the example. Then the book, it's already sine. Yeah, we're using. Let's use cosine instead. So example 2. Integral of cosine power 4, let's say 3x dx. Okay. So if it is an even number, then you need another way. You need to change it differently. Yeah. So how? By keeping the inside function as the square, And then because it's power of 4, then of course it's square dx. If it's power of 6, then it's cos square dx power of 3. If it is power of 10, then it's cos square. So the inside function is always the square one. Okay, the inside function is always the square one. And then what you need is actually the formula, the property of trigonometric function that's related with the double argument. So if you want to take a note, then I will give you the formula that's usually used. The formula that's usually used here is actually cosine square x is actually equal to half 1 plus cosine 2x. Yeah. And sine square x is half 1 minus cosine 2x. So this is the regular formula that is used if it is sine or cosine, power of sine or cosine with the power of an even number. Okay, I hope you follow. So now let's continue. So this is equal to integral of half cosine, yeah, cosine. So 1 plus cosine 6x being squared dx. Okay, yeah. So if I continue, then it's equal to 1 over 4, and then I expand the square. It's 1 plus 2 cos 6x plus cos square 6x dx. Okay, and if I expand, then it's equal to 1 over 4. So the integral of 1 is x. The integral of 2 cosine 6x is actually 1 over 3 sine 6x, yeah, right? And then we have another cosine square. So we cannot do that yet. We cannot do that directly. So you have to change it into cos square 6x dx. Yeah. Now look that this is actually already simpler. And again, if you do it correctly, then actually you may still have an integral, but it's supposed to be simpler. Yeah. So it's from power of 4, now it's square. So again, if you still have the power like the problem, the integral like this, then do the same way. So it's equal to 1 over 4x plus 1 over 12 sine 6x plus 1 over 4 integral of cosine square x. Use the same formula. So it's half 1 plus cosine 12x dx. Yeah. So it's equal to 1 over 4x plus 1 over 12 sine 6x plus 1 over 8 x plus 1 over 12 sine 12x. Okay, that's done. Now we are all done with the integral sign. Now we need to simplify. So it's equal to 1 over 4x plus 1 over 12 sine 6x plus 1 over 8x plus 1 over 796, yeah, 96 sine 12x, and then we combine the like term, we combine the same term, so it's equal to 3 over 8x plus 1 over 12 sine 6x plus 1 over 96 sine 12x plus. Okay, so that's how you do it if you have a even power. Now, what if the combination, what if there is both sine and cosine, but both power is even number? For example, sine square x times cosine power 4x dx. Then again, the same formula will be applicable for you to solve it. Yeah, you still need to use this one to solve this. So you change this into half 1 minus cos 2x. And then you change this into half 1 plus cosine 2x, but being square. And then you can do the step. Okay. So that's the first one. I'm gonna continue for the next lesson. Thank you.